Thanks, Kelly, for the introduction. Hopefully some people were able to hear that. But here's the first tutorial that in a series of 3 about the data that came to us through the Solar Data Bounty Prize. There were introductions for the people who are going to speak. Myself, Tassos Golnas, a technology manager at the Solar Energy Technologies Office. Noreen Gentry, my colleague, also with CITO, and then Robert White from NRO will give the bulk of the presentation. So yeah, let's move to the next slide. So data, right? Data is important, but almost never is an end to itself, right? It's a means to achieve something else. And in our case, in the PV system case, what's important are the models for system performance. And we know that high quality data can help a lot with building and evaluating better models. Now, why models are important? They are critical actually in a number of ways, right? The first one is in the project development and evaluation phase, right? I mean, this is a cash generating asset, the PV system. So a model of its performance, if it's accurate, can give you a good idea how much revenue you're going to get from the system over its lifetime. Once the system is operating, then you need to identify whether it operates according to its specifications and expectations. And again, a good model for system performance will be able to give you the anomalies that you may encounter during operation, any degradation that is either transient or persistent. Right? Very, very important for that aspect of the lifetime of the system as well. So all in all, the models are important. The data help us create better models and obviously achieve better system performance. Why that is important? It's because it will lower the cost of solar electricity and will increase adoption of solar energy across the industry. So in order to support, we can still go back to the previous slide, don't worry. Yeah. So to get high quality data and support this model building and evaluation process, we put together a Solar Data Bounty Prize. And my colleague Noreen will talk more about that and how it went down. But that was the idea, right? I mean, to support the industry and the academia in the research efforts to develop, improve, evaluate, and validate models of real-world PV system performance in diverse environments. Next slide, please. We had about $1.5 million in cash prizes. We didn't give out all of them, so there's was still money on the table when the prize ended. The prize itself manifested in 2 stages. The first stage, we got system metadata, so we knew what kind of systems we're going to have in the competition, as well as irradiance data from those locations to make sure that we didn't have any scam applications. The stage 2 was the key stage for the prize, and that's where the participants submitted their full time series data, the time series data that they wanted to participate with in the prize. The results. Now, once we announce the winners, all the data sets are now shared publicly via a dedicated platform. You see the link, you can download the slides and then click the link and it will get you to the openai.org website. Next slide, please. So to help everyone in the community, right, take advantage of these high quality data sets, right, we have these 3 tutorials this week and 2 more next week. They're about open access data, which is the data we got from the prize, as well as open source tools. These tools are created, maintained by the solar community and the national labs, and they're obviously free for you to not only use, but also available for you to tinker with and contribute to. So these 3 webinars will show you how to first access the datasets from the prize, and that's what we'll cover today. Analyze system performance, and I'm talking about, we'll use at least one of the systems that we have data for through the prize. And eventually, you'll be able to model systems with some of the data that, again, were included in the prize. I'm listing at the bottom of the screen the tools that we'll be using to teach you all these things. And I surely hope that you'll find all these tutorials as useful as they're intended to be. With that, I'll give the mic to my colleague, Noreen. Next slide, please.
Thanks, Tassos, for the great introduction to the data bounty and some of the power that data can help with in our overall goal of solar deployment. So in these next slides, we'll talk a little bit more about the prize winners from the first round of the Data Bounty Prize, and then a little bit more details on the systems and data that they obtained. So Kaylee, you can go ahead and click through these. We wanted to say congratulations to our prize winners, both on the track A, the medium-sized system, and track B, our large-sized systems. So thank you to Island Way Technology, Silicon Ranch, and Wexus on the medium-sized, and to Silicon Ranch and Southern Company that contributed large systems. This is both really impactful for pushing the research community forward and for providing these data sets. So if you go next, by the numbers, thinking about these data sets that we obtained cumulatively, we're really excited about the high quality and diversity of data that we obtained. So you can go ahead and click through these data points. We have 5 different systems across 4 US states, ranging from 110 kilowatts to 257 megawatts, getting over 417 gigabytes of data, which is over 4 billion data points, 9,500 sensor channels with a large average year of 6.6, and then a wide range of different time resolution that we were able to obtain from this. And like Tassos mentioned, this data is available on OEDI and PVDAC, which Robert will take you through in more detail later on. But I've included a QR code here, which if you go to that, then if you go to the next slide, it should bring you to a web page that looks just like this. And if you click on the left-hand side to data source and look at DOE Data Prize, it will give you the 5 different systems from the data prize that were obtained. And then you can look a little bit more through the details of the systems to understand which one it is that you would like to use. So if you go to the next slide, I'll walk you through the high-level details of some of these different facilities. And this is all information that you can find on the website. We just wanted to highlight some of the parameters that people might be interested in. So our largest system was 257,000 kilowatts in a single axis tracking system. We have 7 years of data at 10-second time resolution. And if you go to the next one, we can go through these kind of quickly. People are welcome to look at this later. The Simon Solar Farm, our other really large system, provides a different perspective of a fixed ground system with 5-minute time resolution and 7.8 years. We can go ahead and move forward. Perfect. SR Colorado is a Colorado-based system with CAD-TEL technology, single axis tracking. And then we can go ahead and move forward. Perfect. The Farm Solar Array, which you'll hear more from Robert later on, is out of California and a fixed ground system. So that provides another perspective for you to look at. And then finally, the Maui Ocean Center is a fixed roof mount system that also helps round out our data set. So we're really excited about these different perspectives that will help give people on the modeling and research side different perspectives into PV performance. With that, I'll go ahead and kick it over to Robert, who can actually show you more of the details on how to download this data.
Good afternoon, everyone. Thanks, Noreen, Tassos. I'm a data scientist at the NREL and one of the researchers here, and I'm going to talk about exactly what the data is, why we're storing it where it's at, and how easy it is actually to access and pull down for you guys to use. Now, you're going to hear me interchangeably talk about the OEDI, that's the Open Energy Data Initiative, and that's the platform that's actually hosting the data for us. It's grown out of the OEI, the Open Energy Initiative, which is the project overriding the whole thing. And this grew out of guidance from the administration back around the 2016 timeframe. And then an agreement was made between NREL, the DOE, and the three big cloud providers to put together a platform where we could store the data up there and provide public with the access to the data that we put up there. And we're talking about large amounts of data. Right now, there's about 1.9 petabytes of data sitting up there from a variety of different sources. One of those is the PVDAC data set, of which a subset is the Solar Data Prize. As Noreen told you, it's about approaching a half a terabyte of size by itself. This also fed into the guidelines that NREL has been trying to push forward, which are the FAIR guidelines, which if you're not familiar with that, it's to make all data findable, accessible, interoperable, and reusable. There's more data online if you look up the FAIR guidelines. And as Tassos mentioned, one of the big sticking points for a long time has been that PV data, particularly high quality site data, is difficult to obtain because often it's covered under NDAs. And we've had lots of requests at NREL to access some of our data sets, and most of it has been proprietary and blocked by NDAs. So the establishment of this data prize and getting all of this winner's data and providing it to the public has been quite a boon. And I'm hoping that this will actually catalyze a lot of new research, algorithms, and new insights into the PV that we haven't seen before. And go to the next slide. So first off, just give you a snapshot of what's out there. The Open Energy Data Initiative PVDAC site, you'll see the link down there at the bottom, and later on there'll be some QR codes also. It's actually an Amazon Web Services simple storage solution, which is effectively known as an S3 bucket. If you think about it, it's just a really big hard drive, and all the data is stored in a series of folders on that hard drive. Besides the Solar Data Prize, which you see highlighted in red, there's other data sets that the PV team here at NREL has been adding to this site for quite a while. Some of it is actually dynamic and updated on a monthly basis. That also brings to mind that the way we are archiving, actually the structure of the folders for the Solar Prize data is a little different than the other data, but I think it's pretty easy to be able to access the data sets and pull down the information that you're actually wanting to get a hold of. I also want to mention that there's some other important data lakes on the OEDI that will play into the webinars next week. Particularly the NSRDV data sets are available in the same sets of data lakes that the PVDAC sits in. That is a useful data set to help do data analysis, particularly using their satellite data to either augment or take the place of unavailable irradiance data at the surface. Next slide, please, Kelly. So if you actually go to the website and you click on that red box that I showed in the previous slide, what you're going to find is that each one of the sites has been given a unique identifier number. And I'll show you how those map across in just a moment. But when you click on each one of those sites, what you'll find is there's two folders underneath them, one for the data and one for the metadata. The data folders, you're going to see anywhere between like 4 and 4,000 files inside of them. Depends on how the files were structured, either from the provider or how we were able to extract them from our databases. And the metadata folder will have a single file in it. It is a JSON formatted file, and it's broken into 3 main areas. One is a site and system description, so it gives you all the basic details of the power, the location, and what the date ranges of the system are and more. And I'll show you that file in just a moment. It also has the hardware breakdown of exactly all of the instrumentation that we were provided information on. And then all of the sensor and metric channels, because there's 1 to n number of those panels coming off of each piece of hardware, and it'll describe each one of those. So next slide, please, Kelly. So here's a quick breakdown and a mapping of exactly which numbers go to which sites, so you can find them in OEDI. It's important to actually have these ID numbers because you're going to need them if you plan to use programmatic or API type access to actually pull down the files. And while it may be easy enough to click away at some of the files for the smaller systems and just download them that way, I'll show you in a few minutes, there's an easier way to do it when you're dealing with systems that have 392 plus gigabytes of data on them, which you don't want to sit there and click that number of files. So over on that data side, you'll get a pretty good idea of exactly how many files are probably associated with each one of these sites. And all of this data is also going to be provided on the website that you can actually go to and see as part of the OpenEDI maps. So you can actually look at that and decide, how am I going to download this data? And also, if you're going to download these larger data sets, keep in mind your bandwidth, what you're downloading through, and do you have enough storage space to put this kind of data on? And also, as a caveat, if you actually do have an account on a cloud system like Amazon Web Services, actually transferring the data, including these incredibly large data sets like that 392, is going to move relatively fast. If you are downloading it to an on-prem system or your own laptop, that will take a little bit longer time to actually download the data. Next slide, please. Okay, so now we're going to go into a little bit about the details of what the files look like when you start looking at them and wanting to open them up. Next one, please. So what's in the metadata files? As I mentioned, this is a JSON format file. It's very easy to read. If you're unfamiliar with these, you could actually download this and open it up with your web browser and see it. It is actually an associated nested data source. So it's pretty easy to see how each section leads into the next. The system stuff has got your time zone, your basic metadata of locations and names, the length of the data sets. The site contains all your geolocation information. And then the next area is going to be each section broken into the different pieces of hardware: mounts, inverters, modules, trackers, combiner boxes, weather stations, pyranometers, whatever happened to have been available that they provided data for. Now, not all the systems will have all of those data sets. I mean, your fixed tilt systems are not going to have trackers and so forth. So it depends on exactly the amount of information we were provided from the owners themselves. Also, if you look at some of the hardware systems, you will get manufacturers and models from those. Others, they've opted not to reveal that information, so those will be blanked out or be marked as unknown, so you won't see anything there. And each one of those pieces of hardware produces n number of channels coming out of it. Inverters in particular can produce 5, 10, 20 types of channels coming out of that. And it depends on the system on what channels were provided by the owner. You'll notice that each one of these sections will provide you with the information on what the units that they're in and the name of the actual sensor channel itself. And that's going to be important as you start looking at the data files. Also, there is an indication on whether the aggregation is done on averages. And also it's going to indicate if the actual piece of hardware, where it actually takes that measurement at. And that's marked as a time interval. And that's kind of important because if you've got a 15-minute data resolution on the system, it's nice to know if that data was taken at the beginning of a 15-minute interval, in the middle of it, or at the end of the interval. So that will indicate that. And next week in the webinars, they'll get more details about that. Next slide, please. So as I was saying, inside that JSON file, you've got a unique sensor name. And when you open up the data files, and in this case, I'm looking at system 2107, which is the farm solar array. You'll see that there's a one-to-one relationship between the name that's in the JSON file and one of the headers in the data file for that system. You should be able then to immediately make associations between the metadata and the data that's provided. Now, each file, all of the headers are complete, so you shouldn't have any problem in figuring out exactly what they're associated with. In addition to that, the timestamps have all been checked, and they're all good. And they're all in an ISO timestamp format without the key delimiter between the day and the hour, by the way. And these are all broken into a series of files in the smaller system. It could be broken into electrical, irradiance, environmental, which includes like your wind speed, precipitation, and things like that, and your meter data. In your larger systems, we've broken it up, and it can be either by hardware name, it could be by a timestamp or a range of timestamps, or it could be a mix of both, such as Trackers 2017, Trackers 2018, Trackers 2019. The idea was to break up the files into smaller chunks that would allow you to do the downloads a little easier rather than trying to download some monolithic gigabyte-sized files. Next slide, please. Okay, so this part of it, I'm going to share live the actual PVDAC site so you guys can get an idea of what that looks like. And I believe that's it. Let's see if that's coming through. That come through okay? Yeah, it looks like it. Okay, so what you're seeing there is the landing page if you go to the PV DAC site in the OEDI. Now, inside of the actual OEDI front page, where you're going to find the map, you'll notice that it's openei.org, and the other one is data.openei.org. So one of them is kind of a front end, one of them is kind of the back end of it. Once you're on this site, it's pretty easy then to go where you need to go. You can explore the data map from the front end. We also have a primer here which discusses the actual project and why we're accessing the data to the public, and links to how to cite the data, along with information about the American-made Solar Data Bounty Prize at the bottom. You'll see a variety of resources here, including the direct link into the data sets. And this includes both the PVDAC and the prize data sets. And at the bottom of a whole series of publications where people have cited these data sets as part of the research they're doing. This data portal, if I click that, that's going to take you into the page I just showed you a moment ago. This is the actual entry point into the data sets themselves. But really want to focus on this for just a moment. Once you go to this site, what you're going to see is this map, if you click on the PVDAC map. And as Noreen mentioned earlier, if you only want to find the data sets that are devoted to the prize, there's a filter over on the left-hand side. Clicking that, and that cuts it down to just the data prize. I'm going to shrink it up just a little bit, and Hawaii appears for the Maui Ocean Data Center over there. Now, clicking each one of these doesn't reveal much about it except just some general information. But if you scroll down the page just a little bit farther, there's a table that's a lot of the same metadata I displayed on the table a few minutes ago, indicating exactly which each one of these systems contains. The climate zones, these are Köppen-Geiger indicators and the type of climate zones that are involved with them. Their array configurations, and scrolling over, you get their temporal resolution. And here's that data set size over here again. If you click on the actual link for the name here, you go to a page that's a little more detailed. And we're going to be adding to these pages over the next few months to actually show a little more details about the data that's actually stored with each one of the systems. But you can pretty much see the similar table information here, along with down below information on the PV technology, more on the array configuration, climate zone, and things like that. So jumping back, let's see if I unshare here. How do I do that? There it is. It moved to a different screen. There we are. So Callie, if you can pop up the next slide, please. Okay, so we get down to the meat of it. Actually, how do I get the data off of the site and so I can work with it? There's actually 3 different methods we can go through, and I'm going to talk about a couple of them and just show you the one at the bottom real quick. The first way is just going to the OEDI website. And as I mentioned earlier, as you drill down inside of each one of these, you can actually, and I'll show you in a moment, you just click on it and it downloads the information directly onto whatever system you happen to be on at the time. The second way is to actually use an API. The Boto 3 module application that provides an excellent interface into any sort of S3 repository that allows you to actually operate on the objects that are being stored inside of there, including download them or even opening them up and bringing in the data itself. There's actually a third way using a third module called S3FS. And with that one, you can actually read directly from the OpenEDI archives. And since these are public data sets, there's no credentials that have to be exchanged. You should be able to just simply open them up. So Callie, I'm going to jump into demo mode here again. So if we go back to the main page, which I'll jump to right here. This is the main entry page actually into the data lake. You can click the data lake here. Then it presents you with all of the different sites. We're going to go into 2107. And the reason I'm also targeting 2107 in particular is because the webinars this next week, we've targeted 2107 as our example system to do all of the analysis demonstrations on. So there's both a data page in here, and you'll see there's 4 files in here separated out pretty much like I said earlier. And then there's a metadata file here that's the metadata for the system. And all you have to do is just click it and it's downloaded. So that one's pretty easy. Now, the next step I'm going to show you is that we have a GitHub repository, and the link is on the QR code that I gave you a few minutes ago. And there's a tutorial inside of that. And this will be back up there in a few minutes, the link to get to this. And it's very straightforward to actually run this tutorial. I will indicate that at the very top of the tutorial itself, it actually does a pip install of the PVDAC Access GitHub repository. And this is up on PyPI, so it's pretty straight to be able to just install it and get everything set up to go. I've already run I'm not going to run it now because I've run it previously, but the first step is just to basically get that Boto 3 application module into place. And once it's in place, it's going to do all the work for you. So with this next step, we've got it set up so you can ask which site you want to download. This allows you to actually, if you want to download other ones than just 2107, as I'm going to demonstrate, then this gives you a chance to actually go up there and actually pull down some of those bigger data sets with the same tool if you'd like to. I'm just going to ignore this full path, and it's going to assign it for me in this next step anyway. So I shouldn't have any issues with that. Then the next part, inside the PVDAC Access module, it's actually going to perform all of these steps for you. But I just wanted to bring it up to just show you how simple basically the code setup in Python is to actually do a Boto 3 download of data. And so now the first file inside of this is the electrical file. So it's the largest file that's actually in this repository. So it's going to take a little bit of time, but it's really not that big. So we'll watch it for here a second. It shouldn't take too long to actually start chunking this down here pretty quick. There it goes. There's the first one. The next 3 will come pretty quickly then. So now we've downloaded everything that has to do with 2107. I clicked downloaded the metadata file, and we just downloaded in less than a couple, 3 minutes, all of the data that's inside of it for this data set. So the next section, in case you wanted to actually kind of take a quick view of the data, so I thought I'd show you exactly what's inside the data sets. It shows you that these are downloaded, and we're going to look at this Radiance data set real quick. So I'm going to cut and paste that up there. And then just skip on past that one. It's going to tell us, it's going to actually extract that entire CSV into a single pandas data frame and give us a little bit of information at the bottom of it. There are 531,000 records inside of this single file. There's only one column in this one. They only provided a single POA Radiance channel. So that's all that's here. That's not typical. A lot of the other ones have a lot more Radiance channels than that. And you can see that also its date range is from November 2017 to November of 2023. And if you want to take a quick look at the data set, the last one will actually do a quick plot of the data set just to show you exactly what the data set looks like that it came down from. And so that's kind of the whole process in accessing the data. So it is relatively easy to get to it. So now I'm going to stop out of this. And Kelly, can you start me back up again on the slides? Okay, the last thing is what we'd like you to do is when you use our data sets that we've gotten from all of these great providers and fleet owners out there, we hope that you will actually cite these so we can actually track how this data sets are being used across the community. And there's the site right there on the basic one on how to use it. However, if you do go to that OEDI webpage, there's actually a set of different formats at the bottom, depending on what type of publications or presentations you're planning to do. And that's all the information I've got. Next slide, Callie. If there's any questions, we can go ahead and try to answer those for you.
Robert, can you hear me okay?
Yes, I can.
Okay, great. Thanks everybody and for your patience for my audio issues earlier. We do have 2 questions in the chat that are currently open and a couple that are answered. So let's go through the ones that are open. The first question is there any kind of optimization for time series data in the database?
Out of curiosity, they're talking about inside of our database. We don't have any type of optimization. Well, the actual database that we are using to store this data outside of these files that you're seeing is optimized. It's a Redshift database on AWS that's optimized specifically for time series. However, these files have already been extracted out of that database, and so there's no optimization as far as that goes.
Okay, great, thank you. On to our next question we have is quality_assurance.py file available in GitHub?
Quality assurance files are not available at this moment.
Our next question is the data formatted so that the systems can be readily imported into PVLib Python for verification and validation of the performance data or models?
I'm not going to be able to answer that right off the top of my head on whether that is in place or not. I would tell you to attend the webinars next week, that they're going to be doing some work with PVLib with this same data sets, and they could probably answer that question directly on whether they had to do any sort of translation before importing into the model.
Right. The next question, will NREL provide a downsample version of the largest data set by averages to help people that don't want to work with the specific data?
Yes, this is a discussion that our PV Fleets team has had when we were looking at this data set. That is just, it is quite large at 10 seconds data. The resolution is way beyond what we usually typically work with, which is anything from 1 minute to 15 minutes is what we prefer to work with. So chances are, and when we've discussed this, that we will be in the future working to actually do a roll up and create either a 5 to 15 minute average of that system.
All right, our next question is what sort of quality checks have been done on the raw data?
Quality checks we've done is we've looked for completeness of data. Are there any gaps inside of the data? How large are those gaps? We also looked for stale or clipped data and stuff like that and identified those inside of it. We're not reporting on that. And one of the main reasons we decided not to really adjust the raw data based on problems we saw inside of it, we thought it was important to present the data as best as possible to the community so that they would know that when you're dealing with some of the site data, there are things that you have to do to either adjust, repair, or adapt to in any sort of analysis that you've got. Next week during the webinars, I know that Kirsten's doing and Mike and Bennett are working on, we'll be discussing exactly how to clean those data sets up and get better answers out of them.
Great, thank you, Robert. Kaylee, I'll take this last question for you, if that's all right. So what's the difference between the PV deck public data lake in the 2023 DOE Solar Data Prize on, and then they sent a link here. Looks like that data.openei.org.
So the original PVDAC public data lake was conceived of a lot of the data sets that the PV reliability and durability team had built up over the years. Some of them are actually sites here on our NREL campus that have been producing research data, and even the tops of some of our buildings that we look at the data all the time about. Those are actually updated on a monthly basis into the database where we can, and then they get extracted out into the OEDI system so that people can look at them changing over time. Others are actual research projects we've done for other sites, everything from the Andrew Agassi Academy in Nevada to other sites in New Orleans and everything, that the data was allowable to be publicly disseminated after a time. So it's just provided us a means to actually put public data out there that we previously held inside of our lab or had trouble releasing. The Solar Data Prize is just its own instance of that. Now, there is a little bit of archiving difference. The way that the data for the PV DAC regular systems are divided in daily entries, 1 day and days, months, years, and stuff like that. And there are tools in that PVDAC access repository to download that data. And actually, for any system, it will walk through every data file that's available day by day and concatenate them together and download them for you.
Great. Thank you so much for that, Robert. We have another question here. Do you have any geometric demonstration for the system data, like site plan or just an image of PV system connection scheme, or are you planning to share?
We don't really have any of those from those systems now. We're hoping in the future that we can get 1 or 2 of them to maybe contribute some site diagrams that we can make use of.
Great. Thank you, Robert. Another question here. You mentioned FAIR principles guided the data and metadata structure. Are there specific standards for data channel names or metadata schema that PVDAC follows?
With this set of data, we actually allowed the companies to provide us with the names themselves for each one of the channels without dictating that they actually had to follow certain paradigms for releasing those names and structuring them in such a way. We did go back through it and look at how they were labeled in such a way that they made sense and that they weren't kind of ambiguous about exactly what the channel was. Most of them are marking like inverter _1 _DC _ current and things like that, so that it should be relatively easy to understand. If there are questions after you start digging through the data sets and maybe something doesn't make sense to you, I probably have asked some of these fleet owners when they were submitting this data originally, possibly some of those same questions. So feel free to reach out to me and I'll see what I can do to help you out.
Perfect. And it looks like Tassos is handling this last question here. So that's all we have in the Q&A. Unless anyone else has questions, I'll give it another second. Looks like we have one here. Can CETO share any plans for future data prizes or other means of making PV performance data sets public? Great question.
I'll hand that over to Tassos.
All right, so let me review the question again. So can CETO share any plans for future data prizes or other means of making PV performance data set public? So we cannot talk about future prizes, such as, in the same way we cannot talk about future funding opportunities. Nevertheless, what I can say is that we're cognizant of the scarcity of good quality data, as Robert and I mentioned in the beginning, in this field, and we're looking at ways to make data available to the research community. The prize was such a tool, right, that compensated the owners of data for their willingness, right, to share the data publicly. So obviously, owners of data can always donate data through the OEDI data lake. But again, we reserve the right to see what other opportunities we have in the future to bring more data to the public.
And I can add to that
And to
too. Oops.
To that effect, and Noreen will chime in here, but to that effect, if there is interest in a particular class of PV system data, we would like to hear from you about that.
Perfect. That was going to be my comment as well. While we can't exactly share our plans, we're always listening and always interested in hearing what people are looking for and where the gaps are, so we can understand better what the needs are.
Great, thank you both. Looks like we
With-
have a couple more questions coming in. Tassos, unless you had anything else you wanted to say to that last point.
Yeah, so for this next question, can public subsidies for projects be tied to requirements to provide this data? Obviously, that's an idea that many people have brought forward over the years. It's not as easy to implement, but I think it's a good idea at the core of it. And again, I would try to find ways to implement that. Definitely, some of our projects that we fund mostly through the lab calls, but through FOAs as well, they do encourage the awardees, right, that get DOE money to share the data they generate in the course of the project. Now, obviously there is the question that when people have subsidies such as the investment tax credit to build a plant, what does that mean for sharing the data? Again, that's something that we haven't really tried to implement, but we understand that there is this type of view and probably some merit to it.
Great, thanks, Tassos. Robert, there's a question here about the relationship between timestamp and PV generation amount. It might be easiest for you to read the question.
Okay. Yeah, I see, for example, like at 2023-03 at 1 o'clock, it says 6 kilowatts. What does that mean in time interval time point? That's going to depend on exactly what that channel is coming from. Some of the systems we have, you'd have to look at the metadata to see if that channel is generating an average. So that would be an average over that particular period of time. If that is a cumulative meter, that means that has been over that probably 24-hour period that it's been generating at the time. So it kind of depends on what the source is on that one.
Great, thank you. There's also a question here about providing feedback to DOE on types of data that we would like to see in the future. So we do have a suggested email that I'll have Kaylee drop in the chat, but I did want to open up the group or the question to the group if there are any other suggestions on reaching out to DOE.
So there is a particular email that you guys can use, and we'll find it. I think it's cito@doe.gov or at ee.doe.gov. We'll make sure to include this in the transcript of the questions, Carly.
Looks like Kaylee actually just dropped it into the chat for us here. That's going to be solarprize@nrel.gov.
Yes, and this is much better because the email I mentioned probably goes to the solar office, but if it's something that's specific to the Solar Data Bounty Prize, which is specific to the data availability and relevant questions, that's definitely the right email. Thank you.
Great. It looks like we have one more question here. Are you going to get energy scheduling data for PV systems in this data initiative, or is that out of the scope of this project?
That is out of the scope of this project, right? So maybe in the future, other prizes could request data from systems that have batteries and have schedules for power delivery and all that. But this prize that just ended only requested data that come out from the PV system on its own without any batteries installed.
Great. That was the rest of our questions, unless there are any more. I like to say that because then they pop up magically. Are you planning to share IR data set?
Is it infrared or something else?
I'm not sure.
Maybe you can clear infrared.
Yes, yes.
I don't
don't
we
think-
did not receive any.
I don't think any PV system collects infrared data. Except if you guys are talking about aerial imagery, which is, another concept, right? I mean, you have data collection, not at a continuous time series, but every 6 months or a year or 2 years. This is a subject of research. We're very interested to understand how these infrared images correspond to the performance analysis performed on time series data, and depending on the results of that research, we may try to go that direction too.
Question for Robert here. Is the DC-AC ratio provided in the metadata?
No, that is not provided in the metadata.
All right,
But it
last
should be calculable, right? I
Yes,
mean,
it is calculable. We just didn't ever get it. So.
And there is a question here about the recording being provided somewhere, and I can actually take that. Yes, this will be provided. We will send out a link actually from your registration. So if you registered with your email, you'll get a follow-up. It's also going to be located on the Solar Data Bounty Prize HeroX page. Kaylee, if you could drop that in the chat. It usually takes a couple of days for those recordings to be provided, but you should see all of this, including the slide deck, within about a week or so. Okay, that's the last question. Then I will hand this off. Tassos or Noreen, would you like to close us out?
Noreen, please go ahead.
Well, yeah, thank you everyone for attending this, and to our winners, both congratulations and also thank you for sharing this data with the broader community. We're really excited and looking forward to seeing the impact of these data sets and to being able to, like Robert said, track and follow how they're used and for what purposes. So we think this is a really exciting time and are looking forward to the trajectory from this prize, and also in looking forward to hearing back from you on what's useful and where the gaps still are. So reminder, I know that there have been a lot of different links that have been put in the chat, but reminder that next week there'll be 2 different sessions, one on Tuesday and one on Wednesday. Sign up for those, you won't want to miss them, to go through how to functionally actually use this data. I think that's
it's
all
Tuesday
I have.
and
Tassos, any
Thursday.
final thoughts? Tuesday, Thursday.
Yeah, I think
okay.
it's Tuesday and Thursday. Not much more from me. Again, thanks everyone for dialing in. Definitely don't forget the webinars that will come next week. And what Noreen said, if you have any ideas about the data that might be useful, for the community, please share your ideas with us in the emails provided.
I think with
And thanks
that,
to Andrew for supporting all that. Yeah.
yeah, definitely. I think with that, we can probably give everyone a few minutes back in their day.
Perfect. Thank you, team.